Hello friends, welcome to my YouTube channel is Aviation. Here we discuss about the short simple topic about aviation field. Today's topic of discussion is that why fixed wing aircraft cannot hover or cannot fly at the same location as what the helicopter can do. So to understand that, they are the lift forces which are being generated by the main wing of the fixed wing aircraft, which is required to counter the weight of the aircraft, and when the lift is greater than weight, the aircraft will fly in the air. So for the helicopters, there are main rotor blades which are rotating in one direction and producing the lift, thereby countering the weight. Understanding the lift forces, which I have just discussed, using this picture I will explain. So lift force is equal to half rho v square s c l, where half rho v square is the kinetic energy of the mass flow which is interacting with the aerodynamic surface. So in case of fixed wing, this is a main wing, and in case of a helicopter, this is a main rotor blades, which I have just explained. In this half rho v square, rho is the density of the air and v is the velocity at which the mass of air is interacting with the aerodynamic surface. Surface S is the surface area which describes the area of the wing in case of a fixed wing, and main rotor blade in case of a helicopter. CL is a term where I have to just explain in a bit aerodynamic this. CL is the coefficient of lift, and this coefficient of lift is the characteristic of the wing or blade, as in depending on the attitude or at what angle of attack this blade or wing is interacting with the mass flow, the value of CL changes. If we go further in the depth, there are charts and graph which gives you the value of coefficient of lift as per the angle of attack, and that's how you calculate the lift. So you have the coefficient of lift of the wing, which is the characteristic of the wing or the blade. There is a surface area already discussed, velocity of the relative velocity rather of the mass of air and the surface, density and the constant. So that's how you find the lift force. But the question remains the same, that why the helicopter can hover and the fixed wing cannot hover. So I'll just make it simple to write the lift equation for each of one of them. So lift for rotary wing is half rho v square s of the wing main rotor blade, surface area of main rotor blade, and coefficient of lift for the main rotor blade. And lift for fixed wing is again half rho v square, surface area of the wing and the coefficient lift of the wing. Wing is both main wing and the tail wing, because both are generating some lift. So half is the constant, so we'll remove that. Density is again the same for both, I'll remove it. Coefficient of lift of main rotor blade is having some, as per the attitude which I've already discussed previously, is having some value and will not be 0. Coefficient of lift of wing, main wing and tail wing, is also having some value and will change as per the attitude which I've already discussed. There is a surface area, it will not be 0, it is also having some value, the surface area of the aerodynamic surface, which is the main rotor blade, and surface area of the wing, again the area of the wing which I have already discussed. Coming to the velocity, this is where the velocity of the rotor wing and velocity of the fixed wing, this is where the main difference comes. So velocity of rotary wing, because the blades are rotating always, there will always be a relative velocity between the mass of air m0 and the surface area. There will always be a velocity because main rotor blades are always rotating. So there is a considerate amount of lift which will be generated and will make the helicopter fly at some height from the ground and keep the aircraft there. But in case of fixed wing, if the aircraft is static, if the fixed wing aircraft is not moving, there is no relative airflow between the surface of the aerodynamic surface, that is wing, and the air. So if there is no velocity, the velocity is 0, if the aircraft is static, there is no lift generated. So to produce lift, we always should have a forward motion. So that's why a fixed wing aircraft will have a runway. The aircraft during takeoff, it run on the runway, have a considerate amount of relative airflow between the mass of air and the surface area of the wing, and that's how the lift generates, and that's how the airplane fly. In case of helicopter, even if it is there at one position x and the main rotor blades are rotating, we change the attitude, we increase the CL value, surface area remains the same, velocity is the same at which the main rotor blades are rotating, and we generate the lift, and that's how helicopter can take off and land it from any point. I've used this picture. This is one special case, or special cases are always there. So there are fixed wing aircraft which can take off and land from one location, one position, as same as what helicopter does. So this is a Harrier aircraft, but they do it not with this concepts, but with the concept of a rocket, in which there is a engine and there are the thruster, basically the exhaust or the jet. So when the jet is positioned in the manner where it is giving a thrust at the back side, and there is a counter force, the aircraft will move forward. But in case the jet is positioned 90-degree clockwise direction and giving a thrust down, and with the Newton's third law, aircraft is going up, and that's how this Harrier can, you can see this is the nozzle and this is the air intake and there is the engine, and that's how this Harrier can do takeoff and land. There is a special term VTOL, vertical takeoff and landing, which is a speciality of these kind of aircraft. So in classic manner, majority of the fixed wing, it does require a forward motion. There should be a relative velocity, and that's why a lift can be generated and airplane can fly. But in the rotary wing, it can fly from one location because there is always a component of velocity in the main rotor blade. So here I conclude my video. I hope I have made the basic concept understood. I know majority of you will be aware that there is a main rotor blades are rotating, aircraft can go up, helicopter can go up from the same location, and there is no such case in the aeroplane, that's why it has to move. But I just wanted to put some technicality into it with the equation. So I hope I have achieved that, and if you still have some query about the same video, please let me know in the comment section. I'll try to resolve that. And if you have any other query related to aviation topic, aviation subject, please let me know in the comment section. I'll make the video on that topic. So here I conclude my video. Thank you for being my audience, and please subscribe to my channel. Thank you. Bye.